Tomorrow will be better. A satellite of mass this moves at this speed at a distance of these meters from the center of the earth. Find the force of gravity on it, of course, on the satellite. Follow me, dear friends. Solution. Most candidates, after reading this the first time, will want to apply the formula of the gravitational law, according to which force of gravity will be equal to the gravitational constant, mass of the earth times mass of the planet or of the satellite in question, divided by the square of the distance between the two. What if you didn't remember this? What if you're not able to recall this other constant here? At this point, this formula becomes quite delicate to use. On the other hand, if we consider that satellite motion can be assimilated to circular motion, wherein a satellite moving in an orbit with the earth at its center is like having the center here, which is the earth, and then this circular part here, which is the orbit on which the satellite is moving. And then this distance has clearly been stated that it is from the center of the earth. So no need to add the radius of the earth anymore. In other words, if this is a satellite here, and this is the earth here, then this is the distance you're talking about. So there is some sort of this circular motion here which the satellite is exhibiting. Now, why am I bringing in the notion of circular motion here? This is because we have been told that if this is moving in this circular path, then the force necessary to keep this satellite in this circular path is provided by the attraction from the center of the earth, which is the gravitational force on the satellite. In other words, this gravitational force here is actually the centripetal force necessary to keep this satellite in this circular orbit. And by formula, the centripetal force is given by the mass times the square of the velocity or the speed divided by the radius. This is what we are going to apply. This is pretty easy looking at the information we have. So if you correctly punch this, you have that the mass, which is 285, times the speed 3076 meters per second. You have to square this now divided by the distance from the center of the earth times 10 to the 7. If you correctly punch this on your calculators, dear friends, you should have approximately 63.75 Newton. This is the force necessary to keep the satellite in this circular path. Tomorrow will be better.